So for those of you guys watching along at home, shout out Kate. Kate was like, "Is there a video yet?" I was like, "Oh, shoot, sorry." Or she said something about, because I have an old video up, and it was like I was talking about a test on Monday, and she's like, "Is there a test on Monday? There's no school on Monday." So if you're watching along at home, I got the answer key for the worksheet here. This is the side from 6-4, so I'm just going to scroll through. I've already kind of gone over this with my class here, so I'm just going to scroll through, pause where you need to. Right now. Right now. Okay. All right, any other questions outside 6-4? Okay, flip it over to the back, please. Here's side 6-5. So for ones like 4, where do I get the -2? Where do you come up with the -2? From the calculator, right? From the 0 in the calculator. You try to find where the function crosses the x-axis, and it crosses at -2. It also crossed at -4. Actually, it didn't even cross it. It bounced off, right? So you could have done a -4 if you wanted to, and you could have done it twice if you wanted to, because it did bounce. Remember, bouncing off of is at least a double root, an even root. Bending through is an odd root, at least 3. Going straight through is a single root. And here's number 6. See, for this one, we would have seen it cross at 6 and 3. Now, no matter what, if you wanted to do 6 first, or whether you wanted to do 3 first, doesn't really matter, because you get to the same spot either way. See, this step down here with the x minus 3, x minus 6, x squared minus 4, x plus 1. Everybody should have gotten there. No matter which route you take, you should get to that step. And once you get to that quadratic, you either use quadratic formula or completing square to solve for your last set of zeros. Now, don't worry about the factor part here. Okay, I'm really only worried about the zeros. 3, 6, and 2 plus or minus radical 3. I would strongly encourage you guys to refresh your memory on completing the square, because, I mean, it's just a lot more useful. Like, look at this one. X squared minus 4x plus 1. You subtract a 1. Hold on a second. You subtract a 1, and then you find -4 divided by 2 is -2, squared is +4. So remember, gets you x minus b over 2, or x plus or minus b over 2, which is 2 in this case. We got 3, and now we square root. X minus 2 is equal to plus or minus radical 3, and then we add 2 plus or minus radical 3. That just gets you there a lot easier. So we got 3, 6, and 2 plus or minus radical 3. Or there are 4 roots there. The first one is 2 plus radical 3, which is just a decimal, right? Radical 3 is just a little under 2, like 1.8 or something like that. And so it's like 2 plus 1.8, 2 minus 1.8. All right, here's 8. Again, don't worry about the factor part. Just the zeros are fine. Again, you would have put this into your calculator and seen that it crosses at 1 and -3, but you can choose to do 1 or -3 first. It doesn't really matter which one you go first. You get this step in the end. So I've got x minus 1, x plus 3, x squared plus 6x minus 2. And then there's the work for quadratic formula. Or if you wanted to do completing the square, x squared plus 6x, let's add the 2 over. So I'm going to add 9 to both sides. So x plus 3 squared is equal to 11. So plus or minus radical 11, -3 plus or minus radical 11. And then number 9, the volume of the box problem. The width is x, the length is 2x, and the depth is x minus 2. So then you multiply all of those things together, and set it equal to 64 because that's the given volume. So you should get 2x squared minus 4x, 2x cubed minus 4x squared, and then you subtract over the 64 to get what you have for a there, 2x cubed minus 4x squared minus 64. You factor out the 2, and then that's not factorable. Don't worry about this possible rational roots thing. We'll get to that in a couple days. And then we have, I'm sorry, yeah, I forgot to tell you that. You didn't have to do part B for that possible rational roots. But at any rate, you plug this into your calculator and see where that crosses the x-axis, and it crosses at 4, and then 2 other pieces, which end up being non-real, so they get thrown out. So the only plausible answer is 4. So the width is 4, the length is 8, and the depth is 2. Somebody asked me, well, if we see in the calculator that it only crosses once, at one real spot, do we have to worry about any of the other zeros? And I said no. So if you know that the other zeros are going to be non-real, you don't have to worry about them being solutions. Now, if they cross the x-axis, then you better check them, right? These will not cross, those 2 zeros do not cross the x-axis because they're non-real. Okay. All right, questions on the homework?
If you fail your test or your permit test, do you have to pay for it the second time you take it?
I'm pretty sure.
I don't know.
What did you say?
I don't know.
You failed it 3 times.
I mean,
Yeah, no problem.
I feel that.
Yeah,
I am by no means the smartest person, and I didn't feel that.
all right.
Because you know, it actually stupid stuff like what happened to the hospital you were in. So
Get out of the car.
I'm really a sign that I'm
Well, depends on what.
What part of the breaking when you're thinking
All right, as you get in the guided notes, there's this top part, and we're not actually going to do this top part right now. There's a little warm up on there. We're not going to do that. We'll do it later. I promise.
What are you calling, Caleb? I want a break.
what is that? What about Oh, I know, that's why we're
120, 120 up.
Yeah.
I hate them.
No problem. All right, so section 6.6 day 1. Kind of give you guys a heads up on where we're headed. The schedule over the next week or so. Today we're going to do section 6.6 day 1. No school Monday. On Tuesday we're going to do section 6.6 day 2. Review Wednesday, review Thursday. Quiz on Friday of next week over section 6.4 through 6.6. Okay? Now, let's kind of recap everything that we've learned thus far in section 6.4 and 6.5. Basically what you know is that roots correspond with zeros, and that you can factor to get those zeros, or you can use your calculator to get those zeros. That's really all we know right now, right? If you want to find the zeros of a polynomial, you can either factor it or use your calculator to assist you in factoring that polynomial, okay? Once we get past section 6.6, once we get past next Friday, that quiz next Friday, I will teach you a way to do that without a calculator, okay? Because there's got to be a way, right? There's got to be a way that you can solve for the zeros, even if it's not factorable. There's got to be a way, and that's what you see with that rational root theorem that I forgot to tell you not to do, the P's and Q's and stuff, possible rational roots. But for right now, we are going to be able to use our calculator, and that will assist us in factoring, okay? So let's kind of review everything that we've learned. All of these things are equivalent statements. Synonyms, right? Synonyms. Any real number r is a root of the polynomial equation if p of x is equal to 0, right? So you set the function equal to 0 and you solve. You can call that a root. You can call that a solution. You could call that a 0. You know that if you plug in a root into a function, the output should be 0, which makes sense because in the following row there you see, well, that means it's an x-intercept, right? If you plug it in and the output turns out to be 0, then you know it's got a coordinate, that root comma 0, which means it's an x-intercept. You also know that x minus r is a factor. Every root corresponds to a factor. Every single root, no matter if it's non-real, no matter if it's irrational, it will correspond to a factor. And also, when you divide that function by that root, the remainder is 0. Right? This is why we can use synthetic division to test out to see if something is a root. So, and obviously also r is a 0, right? R is a 0, r is an x-intercept, r is a root, whatever you want to call it, right? All of those things are equivalent statements. That's really kind of what we've learned. Now, we can use this information to actually work ourselves backwards. If I say, okay, I've got -2, +2, and 4. I know these are the zeros of a polynomial. What's the simplest polynomial that also has those roots? Well, we've kind of done this before with quadratics. We've done this before. But the problem with quadratics is there's only possibility of 2 roots. Now I've got 3 roots. How does that work? Well, it works honestly the same way. I tell you that x equals -2. I tell you that x equals +2. And that x equals +4. That's what that means, right? And we know that if x equals those numbers, there's got to be corresponding factors that align with those roots. X plus 2, x minus 2, and x minus 4 are the factors that correspond to those roots. And we know that if you want the full polynomial and those are the factors, well, factors you just multiply back together to get the full number, right? So same thing with polynomials. You multiply the factors back together to get the full polynomial. So that's what we're going to do. Let's multiply our first 2 together here, x minus 2, x plus 2, because that looks like a difference of squares to me. So f of x is equal to my first, x squared. Notice that my outers, -2x, and my inners, +2x, they will cancel. What's unique about the difference of squares? A +2 and a -2 make -4. Multiplied with another x minus 4 that we haven't used yet. And now we FOIL this piece here. F of x is equal to, we got x squared times x squared times -4, -4 times x, -4 times -4. And that's the simplest polynomial that has those 3 roots. Is that the only polynomial that has those roots? No. You know what else has those roots? 2x cubed minus 8x squared minus 8x plus 32. What did I do? I just multiplied everything by 2. I could multiply that by any whole number, right? And all that's doing is vertically stretching it. Does vertically stretching, because it would be a times f of x. So just multiplying that entire function by a number change the zeros? Does vertically stretching change the x-intercept? No. So I could really multiply that function by any constant, and it would not change the zeros. So that's why I say let's go with the simplest polynomial that has those given roots. Okay, let's do that again. Let me ask you something here. How many roots did I have?
3.
What was my degree? Okay, hold on. Let's do that. Let's do this again, and then we'll look at that as well. I've got 0, 2/3, and 3. All right, so that means I've got x equals 0, x equals 2/3, and x equals 3. I've got nothing to do here with my x equals 0. That's the factor. Now, please, please, please do not try to use 2/3. Don't do this. We want simple. It's not technically wrong if you use 2/3, but it's going to be a lot more difficult. So here's what I suggest you do. Multiply the 3 over to the other side first. Then subtract the 2. And use that factor. That's going to be a lot easier to work with than an x minus 2/3. Isn't that factor still going to get you 2/3 as a root? Yes. And then we have x minus 3. All right, so my function is going to be equal to x times 3x minus 2 times x minus 3. Let's multiply these two pieces together. 3x squared minus 2x. And then let's multiply it in with the x minus 3. Spoil that. 3x squared times x is a 3x to the third. Minus 9x squared. Minus 2x squared. Plus 6. X. Dramatic pause. Sorry. Combine like terms. 3x cubed minus 11x squared plus 6x. Questions about that? If you were to have used 2/3, you would get all sorts of messy fractions. You don't want to do that. Trust me. Okay, how many roots did we start with? What was my final power? My final degree was 3. That is really what's called the fundamental theorem of algebra. It's funny that this has such like an epic name. It's the fundamental theorem of, you're in the second semester of Algebra 2. How do we just now get to the fundamental theorem of algebra? I don't know. I don't even know why that's called that. Because it's like a useful thing, but it's not like fundamental.
Is this the presentation you did at your calculator convention?
No.
Why is it not considered fundamental?
Right. Let's change this name to the theorem of algebra, or a theorem of algebra.
A singular.
Yeah. A generic, right?
Very neat.
A useful.
A used rarely.
Yeah, all right. We noticed that the degree of the function in example 1 is the same as the number of zeros. Okay. Now, go with me here. Kind of pay attention. Well, hopefully pay attention here. Think about this. I just said that the number of zeros must equal the degree, right? So if I graph for us x to the third, let me get this out of the way. If I graph for us x to the third, how many zeros should I see? 3. But wait a sec. We know what x to the third looks like. How many times is it actually crossing the x-axis? Once. So here's what we have to think about. Just because it crosses once, doesn't, in a cubic equation, doesn't that actually represent 3 roots there? How do we know?
Because it's like curvy.
Because it bends through. Okay? It bends through. So we have to include multiplicities. We must include multiplicities. Also, what if I did x squared plus 4? I said, okay, the degree of the polynomial has to be equal to the number of zeros it has. Does that have any zeros? I should be careful when I say that. Does it have any real zeros?
No,
What are the zeros?
not real.
Correct, yeah. Imaginary, they're not real, right? I gotta kind of set that one up, right? They're not real, they're imaginary, right? Think about x squared plus 4, the roots are plus or minus 2i, right? They're non-real. So, basically what we're saying is the fundamental theorem of algebra basically says that, and the corollary is more important than the actual theorem. Every polynomial function of a degree greater than or equal to 1 has exactly n zeros, including multiplicities, including complex roots, including irrational roots. Okay? Because even though they're non-real, even though they're complex, they are still roots of the equation. Even though they're multiplicities, they are still roots of the equation. Okay? So, let's take a look here. X to the fourth minus 3x cubed plus 5x squared minus 27x minus 36. I mean, we could have kind of, seen that this was going to happen, right? All along, we've been kind of seeing this pattern that the number of roots actually correspond to the number of zeros that we've got. Well, I'm sorry, the degree of the polynomial actually corresponds to the number of zeros we have. But let's take a look here. X to the fourth minus 3x cubed plus 5x squared minus 27x minus 36. First route would be to try to factor this down. Does this factor at all? No. There's no GCF, and there's no 5-term branch of that, flowchart. So, well, what do we do now then? We go to your calculator, and you say, okay, I've got x to the fourth minus 3x squared, cubed, plus 5x squared minus 27x minus 36. I'm just going to double check that. X to the fourth minus x to the third plus 5x squared minus 27x minus 36. And I go to graph it. Okay, it looks like it crosses twice. Once there, once there. How many zeros should there be? There should be 4, right? I only see 2. Are there any multiplicities that you see? Are there any multiplicities? No, they're going straight through, right? The multiplicity of all of these is 1, right? It's going straight through. It's not bending, it's not bouncing, nothing. It's just going straight through. So that means that for me to get another 2 zeros, I bet they're non-real. Let's check and make sure. Now, this looks like it's x equals -1. This looks like it's x equals 1, 2, 3, 4. Which one do you guys want to do first? 4. Okay, 4. Let's run 4 through synthetic division. 1, -3, 5, -27, -36. Okay, here we go. 1, 4, 1. Okay, it was indeed 4. Good. How do I know it was definitely 4? Because the 0. All right, now let's remember that root corresponds to this factor. And then I've got x cubed plus x squared plus 9x plus 9. Now, here's the deal. I can factor this now. But do I absolutely have to factor? No. I could factor this by grouping. But did I use a -1 yet? Can I? Sure.
What's the advantage to not just factoring?
What's the advantage to not factoring?
Yeah.
Because I think synthetic division is easier.
Oh, really? Okay. You're wrong.
Done.
Okay. Yeah, but I'm done too.
No, I was done faster.
I had that whole conversation.
No, I was done faster than you. And then we got an x plus 1, x squared plus 9.
You know how I got that?
No.
Okay, me neither. Must be some lucky there.
So I've got x equals 4, x equals -1, and once it gets down to a quadratic, if it's not factorable, which that is not factorable, right? We can't make that x minus 3, x plus 3. That's a sum of squares, not a difference of squares, but that is not factorable. Once it's not factorable, and I've got no more zeros to go from the graph. I have to use some sort of other method to solve with this quadratic. Luckily, it doesn't have a b term, so I can just solve directly for x. So plus or minus 3i. We subtract the 9 and we square root it. Square root of negative 9 is plus or minus 3i.
What is going on?
Sound like they're having fun.
WWE Fight Night. All right, ladies and gentlemen, we will be right back after this quick ad from Raid Shadow Legends.
He's literally recording.
Hey, I got a fruit roll at the I found it, dude. I think I got it during lunch. You ever eat it? Yeah, dude, I bought it during lunch.
This video, make sure to like and subscribe. Make sure to like and subscribe for 100 subscribers.
I already said we're sponsored by Red Shadow.
We need to have like a calculator at pop up on some screen.
We go open the
Like
calculator.
here, to get your
How do I do that?
Texas instruments. Well, I don't know.
I gotta go see what she's doing. She's like,
Maybe there's a fire.
Our adjacent math teacher is climbing into the ceiling.
For those of you at home, our building is currently on fire.
We are extremely distressed, as you can tell by the voice.
This is not a smoke signal. The building is on fire. Send help.
This is not a drill.
This is not a joke nor a drill. Please send medical help.
It may or may not be a joke.
so she teaches, and then sometimes she has the kids work on whiteboard, and then she sets them up on the garage door. Well, the kids forget and then throw the garage door up, and the whiteboards end up above the ceiling tile. So she's like trying to get them all down now.
Threat has been eliminated. Please do not send medical help. I was narrating what was happening.
We did a little commercial break.
Oh, did you? Okay. Is this your next one? Is this your last one?
Not like any
Minus
action
228.
watch. You can say this password to find the information.
Yeah.
Because the rest of these notes, whatever I've got on the rest of the slides, we'll do on Monday. This will be the last one that we'll have today. Oh, we got 14 minutes. Oh, it's snowing outside.
It's gonna be a fun one today.
For those of you at home, it's snowing outside.
Sorry, Kate. This is a bad video, Kate. I apologize,
It's
Kate.
probably not the only one.
All right, here we go. Jerry's watching.
Yeah, Jerry.
Did you see Jerry's commenting again? He's trying to lobby for a free day for you guys.
Did he actually?
He
No
said you
way.
should give them a free day.
No way.
Shout out, Jerry.
Respond to your thing. I think you should.
Thank you, Jerry. You're a hero.
What's that?
I
Jerry.
think you should do daily shout outs.
Daily shout out.
Jerry, give us a shout
Yeah.
out.
Jerry, we noticed you. We noticed.
I know. I saw you comment that. Well, I got COVID and then it didn't happen and then I'll do it. I promise.
It's a long weekend.
Okay, maybe I'll do it this weekend.
Yeah.
Jerry, my favorite video of yours as a fan, I have to say, is the Sex Sucker Challenge. A personal favorite for me. I watched it during this class while I was supposed to be doing work. Just thank you. Thank you.
Okay, there we go.
We
All right.
definitely.
So can I factor this at all? No, I cannot factor this. So what we have to do is go to our calculator, go into our y equals, and start plus 11x cubed. What? I have no idea what it is. It must be a Friday.
He's probably taking his class and just using this to get all the answers.
Yeah, really. I wonder if they use the same book or something. All right, here we go. Again, how many zeros should I have in the end? 4. Okay, I should see 4 zeros. And I guess I didn't even say it. Did we see all 4 here in the last problem? 1, 2, 3, 4.
Yes.
Right? The plus and the minus. Positive 3i, negative 3i. So I got a little distracted. All right, so looks like it's a 2. Negative 2, excuse me. And then it looks like a 3. You want to use 3?
Why would you not listen to positive?
I don't know. Let's run a 3 through. 1, 11, 20, negative 110, negative 228. All right, so that's a 1, a 3, a 14, a 42, a 62. No, 60, yeah, 62. Escalated quickly. What's 62 times 3? 186? And then, so 76, so 228. Zero. Go for it. Try it. X to the third plus 14x squared plus 62x plus 76. And now we would try to factor by grouping, but it doesn't. But I didn't even need to factor by grouping anyway. I could have just reduced out a negative 2 because we see it from our calculator.
Those of you listening at home, are you guys wrong?
I'm right.
Jerry, don't, he's brainwashing you. He's trying to use you to get a shout out to gain more subscribers.
It's all just a plot.
It's all just a ploy. You're all just pawns in my game. X plus 2, remember that corresponds to an x plus 2. And we're left with an x squared plus 12x plus 38. And I would see if I could possibly factor that quadratic. I cannot. You're going crazy over there.
Mr. Monty.
Is Monty over there now?
Yeah, I just got him out.
So I've got x squared plus 12x plus 38. And I've got x equals 3 and x equals negative 2. What do you guys want to use? Quadratic formula, complete the square.
Synthetic division. Oh wait, it doesn't work here, does it?
You're right, it doesn't work. What can I use? Or what do you want to use? Quadratic? Okay. Lame. The opposite of b plus or minus the square root of 12 squared minus 4ac all divided by 2a. We go inside our radical. 144 minus 4 times 1 times 38. Negative 8. Negative 12 plus or minus the square root of negative 8, all divided by 2. Okay, the square root of negative 8. The negative gets an I, and then the square root of 8 is 2 radical 2, because it's 4 times 2. So negative 12 plus or minus 2I radical 2, all divided by 2. Reduce the fraction. So I'm going to get x equals negative 12 divided by 2 is negative 6. And then I've got to reduce a 2 out here, so I radical 2. So I've got all 4 roots. X equals negative 3, x equals positive 3, x equals negative 2, x equals negative 6 plus radical, I radical 2, x equals negative 6 minus I radical 2. So those are my 4 roots. The plus and then the minus.
Wait for which one? The last
The
one.
pl-
Okay. Okay. Oh.
Does that make
yeah,
sense?
I missed that, yeah.
Questions about that? Homework is up there on the board. Page 449 to 450, 12 to 18 even, 22, 24 to 30.
Jerry, if you give us a shout out on your 250 subscriber channel, there'll be no homework.
That's a lie.
For you, no, for Jerry.
For Jerry.
Jerry gets that
This
one.
one's for you, Jerry. I hope you're listening.
See ya.